87%. That's how many F6F Hellcat pilots died from something other than enemy action during World War II. Not shot down by Japanese fighters, not destroyed by anti-aircraft fire. They died from causes that never made it into the history books, never appeared in the combat reports, and never earned anyone a medal. The numbers are shocking when you look at them closely. The F6F Hellcat achieved a kill ratio of 19-1 against Japanese aircraft, 19 enemy planes destroyed for every Hellcat lost in air combat. It was the most successful fighter aircraft in naval aviation history. The Hellcat destroyed 75% of all Japanese aircraft shot down by U.S. Navy pilots during the Pacific War. It dominated the Zero, the aircraft that had terrorized Allied forces in 1942. By 1944, Japanese pilots feared the distinctive round nose and massive engine of the Grumman fighter. Yet for every Hellcat pilot killed in combat, 6 more died in accidents, mechanical failures, and operational losses that had nothing to do with the enemy. A young aviator was far more likely to die attempting a night landing on a pitching carrier deck than in a dogfight with a Zero. Engine failures killed more pilots than Japanese bullets. The vast Pacific Ocean claimed aircraft that ran out of fuel before finding their carriers, crews lost in storms, or fighters that simply disappeared without explanation. This was the secret that the Navy didn't publicize. While newsreels showed Hellcats shooting down Japanese planes and protecting the fleet, they didn't mention the pilot who crashed on takeoff because his engine failed. They didn't show the fighter that missed all the arresting wires and went over the side into the ocean. They didn't talk about the 4-plane division that flew into a tropical storm and was never seen again. The Pacific War was fought across distances that made Europe look compact. Carriers operated hundreds of miles from land. Navigation relied on dead reckoning and basic radio beacons. Weather forecasting was primitive. And every single landing on a carrier deck was an emergency waiting to happen. This is the story of how the Navy's best fighter became a death trap for reasons that had nothing to do with combat, and why 87% of Hellcat pilot deaths came from the hidden enemy that no amount of gunnery skill could defeat. To understand the Hellcat's paradox, dominant in combat, yet deadly in operation, requires going back to 1942, when the U.S. Navy faced a crisis. The Japanese Zero had proven superior to every American fighter in the Pacific. The F4F Wildcat, Grumman's previous carrier fighter, was tough and reliable, but slower and less maneuverable than the Zero. American pilots were getting killed, and the Navy desperately needed something better. Grumman's design team, led by Chief Engineer William Schwendler and Project Engineer Richard Hutton, had been working on a Wildcat successor even before Pearl Harbor, but the urgency of 1942 accelerated everything. They had to create a fighter that could outperform the Zero while being rugged enough for carrier operations, simple enough for rapid mass production, and reliable enough for pilots with limited training. The solution was the F6F prototype, which first flew on June 26, 1942. Grumman's engineers made crucial decisions that would define the aircraft's character. They selected the massive Pratt & Whitney R2800 double wasp engine, the same power plant used in the P-47 Thunderbolt, producing 2,000 horsepower. This engine was larger, heavier, and more powerful than anything previously installed in a carrier fighter. The airframe was designed around that enormous engine. The fuselage was big and heavy for fighter standards, giving the Hellcat its distinctive bulky appearance. But this size brought advantages. More internal fuel capacity meant longer range. Additional structural strength meant the aircraft could absorb tremendous battle damage. The wide-track landing gear, which folded backward into the wings, provided stability during carrier landings. Armament was concentrated in the wings, 6.50 caliber Browning machine guns with plenty of ammunition. Later models would carry rockets and bombs, transforming the Hellcat into an effective ground attack aircraft. The bubble canopy provided excellent visibility, crucial for spotting enemy fighters before they could attack. Test flights revealed an aircraft that wasn't particularly graceful or maneuverable at low speeds, but excelled at what mattered most. It was fast, could climb rapidly, and remained stable and controllable at high speeds where combat actually occurred. The Navy ordered the Hellcat into immediate production, and Grumman's factories began churning out fighters at an unprecedented rate. By October 1943, the first Hellcat squadrons reached the Pacific. Pilots transitioning from Wildcats found the new fighter more demanding to fly. It was heavier, faster, and less forgiving of mistakes, but it could finally match the Zero in combat. The Hellcat could outdive the Japanese fighter, had better high-altitude performance, and could absorb damage that would destroy a Zero. Most importantly, it could dictate the terms of engagement, choosing when to fight and when to disengage. The Hellcat's combat debut at Marcus Island in August 1943 set the pattern. Navy pilots shot down numerous Japanese aircraft while losing few of their own. The kill ratios that would define the Hellcat's legend were already emerging, but so were the operational losses that would ultimately claim far more lives than combat.
Landing a fighter on an aircraft carrier has been described as a controlled crash. Landing a Hellcat on a carrier at night, in rough seas, low on fuel, possibly damaged, with minimal instruments, that was something else entirely. It was the most dangerous thing naval aviators did, more deadly than facing enemy fighters, and they did it repeatedly throughout their deployment. The numbers tell a sobering story. During World War II, the U.S. Navy lost over 5,000 aircraft in operational accidents aboard carriers. Deck crashes killed hundreds of pilots and deck crew. Aircraft went over the side into the ocean. Barrier crashes destroyed planes and injured personnel. The carrier deck was the most dangerous 4 acres in the world. A typical carrier landing sequence began miles from the ship. The pilot had to locate the carrier, not always easy in the Pacific's vast expanses, especially if weather obscured visibility. Radio homing helped, but equipment failures or radio silence during combat operations meant pilots sometimes searched for their carriers with fuel gauges dropping toward empty. Once the carrier was spotted, the pilot entered the landing pattern, joining other aircraft circling the ship. The landing signal officer, LSO, stood on a platform at the carrier's stern, holding colored paddles. He would guide each aircraft to the proper approach angle and speed through a series of paddle signals that pilots had to interpret instantly. The Hellcat's approach speed was relatively high, around 85 knots, nearly 100 miles per hour. The pilot had to maintain precise control while watching the LSO, monitoring instruments, and preparing for immediate action if the landing went wrong. The carrier was moving, typically heading into the wind to provide additional airflow over the deck. But the deck was also pitching and rolling with ocean swells. As the Hellcat crossed the carrier's stern, the ramp, the pilot cut throttle in response to the LSO signal. The aircraft dropped onto the deck, tail hook extended to catch one of the arresting wires stretched across the landing area. If everything went perfectly, the hook caught a wire and the Hellcat jerked to a stop in less than 300 feet. But perfection was rare. Pilots came in too high or too low, too fast or too slow. In these cases, the aircraft either missed all the wires, a bolter, requiring an immediate go-around, or crashed into the barriers designed to prevent planes from hitting aircraft parked forward. Barrier crashes destroyed aircraft and injured pilots. Some pilots were killed instantly in particularly violent impacts. Night landings multiplied the danger exponentially. Depth perception disappeared in darkness. The ocean and sky merged into black. Pilots relied on a few lights on the carrier and their instruments, but darkness distorted everything. The accident rate for night landings was several times higher than daylight operations. Some squadrons lost more pilots to night landing accidents than to combat during their entire deployment. Weather added another layer of lethality. Tropical storms appeared with minimal warning. Rain reduced visibility to near zero. Wind gusts threw aircraft around during approaches. Pilots attempting to land in deteriorating conditions sometimes crashed, while others had to ditch in the ocean when fuel ran out before they could land safely. Then there was the simple fact of carrier deck operations under combat conditions. Pilots launched on missions exhausted, having flown multiple sorties over days or weeks. Combat stress accumulated. Sleep deprivation affected judgment. A pilot making his fourth landing of the day after hours in the cockpit and a combat engagement that left him shaking with adrenaline was far more likely to make a fatal mistake than a rested aviator in ideal conditions. Lieutenant Alex Vrachu, one of the Navy's top aces with 19 confirmed kills, nearly died not in combat, but attempting a landing after a mission. His Hellcat's tailhook failed to deploy properly, causing him to miss all the wires and crash into the barrier. He walked away, but the aircraft was destroyed. Vrachu survived the war, but many of his squadron mates didn't, and most died in operational accidents rather than combat. The Pratt & Whitney R2800 was one of the most reliable piston engines ever built. It powered thousands of aircraft throughout the war with remarkable success. But reliable didn't mean perfect. And when an engine failed over the Pacific Ocean, hundreds of miles from the nearest land, the result was often fatal. Engine failures killed Hellcat pilots with depressing regularity. Some failures were catastrophic, pistons breaking, crankshafts snapping, connecting rods punching through cylinder walls. These failures often occurred without warning. One moment the engine was running smoothly, the next it was seizing in a spray of oil and metal fragments. A pilot experiencing catastrophic engine failure over water had limited options: attempt to glide back to the carrier if close enough, or prepare for ditching. Other failures were progressive: oil pressure dropping, temperature rising, rough running that indicated internal damage. These gave pilots warning, but presented agonizing choices. Continue the mission and risk complete failure away from the fleet? Turn back immediately and abort. Push the failing engine and hope it held together long enough to reach the carrier. Maintenance standards were high, but conditions weren't ideal. Carriers operated continuously, with mechanics working around the clock to keep aircraft flyable. Salt spray corroded everything. Tropical heat and humidity accelerated wear. Sand and dust infiltrated engines during operations near island airstrips. Maintenance crews did remarkable work under difficult conditions, but they couldn't catch every impending failure. Some engine problems stemmed from combat damage that wasn't immediately apparent. A Japanese bullet might damage an oil line without causing immediate failure. The leak would worsen in flight until suddenly the engine seized from oil loss. Shrapnel could nick fuel lines, creating slow leaks that left the aircraft short of fuel. Pilots who survived combat sometimes died from damage they didn't know they'd sustained. Fuel management presented its own challenges. The Hellcat carried fuel in multiple tanks, main tanks in the fuselage and drop tanks under the wings. Pilots had to switch between tanks at the proper times and ensure fuel distributed correctly. A mistake or a stuck fuel selector valve could leave a pilot with a dead engine despite having plenty of fuel aboard. The R2800 engine consumed fuel rapidly at high power settings. Combat operations, dogfighting at full throttle, depleted tanks alarmingly fast. Pilots had to constantly balance mission requirements against fuel remaining. Too aggressive, and they'd burn too much fuel to make it back to the carrier. Too conservative, and they might not complete the mission or defend themselves effectively. The Pacific's vastness compounded every problem. In Europe, a pilot with engine trouble might glide to an emergency landing on land or bail out over friendly territory. In the Pacific, the nearest land might be hundreds of miles away, controlled by Japanese forces. Ditching in the ocean meant hoping rescue aircraft could find you before sharks, exposure, or Japanese patrol boats did. Rescue operations saved many downed pilots, but not far from all. Submarines stationed along flight routes, lifeguard duty, picked up survivors when possible. Float planes searched for downed aviators, but the ocean was vast, and a single pilot in a raft was a tiny target. Many pilots ditched successfully, only to die waiting for rescue that never came.
Getting lost in the Pacific Ocean was easier than most people realize, and pilots who couldn't find their carriers often didn't survive. The ocean offered no landmarks, no roads, no visual references. Navigation relied on dead reckoning, calculating position based on heading, speed, and time, with all the accumulated errors that implied. The Hellcat's navigation equipment was basic by modern standards. The pilot had a compass, an airspeed indicator, a clock, and a plotting board. Radio direction finding could help locate the carrier if equipment worked and conditions permitted, but radio navigation had limited range. Equipment failed, and radio silence during combat operations meant pilots sometimes couldn't get bearings when they needed them most. Weather complicated everything. Cloud cover obscured the sun and stars, making celestial navigation impossible. Wind pushed aircraft off course, and wind speed and direction changed with altitude. A pilot flying in clouds might emerge miles from where he expected, with no immediate way to determine actual position. Group formations helped. Multiple aircraft could share navigation duties and spot errors, but formations broke up during combat. Pilots pursued enemy aircraft, became separated from their divisions, and then had to navigate back to the carrier independently. A pilot who'd been focused on a dogfight suddenly had to figure out where he was, where the carrier was, and whether he had enough fuel to reach it. Some pilots simply miscalculated. A heading error of just a few degrees, maintained over an hour, could put an aircraft dozens of miles off course. Miss the carrier by 50 miles, and you might never find it, especially if fuel was low. The Pacific was littered with the wrecks of aircraft that ran out of fuel searching for carriers that were just over the horizon. Radio malfunctions left pilots unable to call for help or receive navigation assistance. A damaged radio meant flying alone with no way to communicate. Even with working radios, atmospheric conditions sometimes made communication impossible. Solar activity, weather, and distance all affected radio propagation. Night operations magnified navigation challenges. Everything was harder in darkness. Visual references disappeared. Fatigue affected judgment. Pilots returning from night missions sometimes flew right past their carriers, not seeing them in the darkness, continuing until fuel exhaustion forced them to ditch. The infamous Flight 19 incident, 5 Navy Avenger torpedo bombers that disappeared in the Bermuda Triangle, illustrated how easy it was to get lost even with experienced crews. While Flight 19 didn't involve Hellcats, it demonstrated the navigation challenges that all Pacific aviators faced. Disorientation, equipment problems, and bad decisions combined to cause catastrophic outcomes. Tropical storms, typhoons, and sudden weather changes killed more Hellcat pilots than many realized. Weather forecasting in the 1940s was primitive compared to modern standards. Satellites didn't exist, radar was basic. Weather reconnaissance consisted of aircraft flying into storm systems to observe conditions, dangerous work that didn't always provide adequate warning. Typhoons were particularly deadly. These massive storms generated winds exceeding 150 miles per hour, waves towering 50 feet high, and conditions that made flight impossible. Carriers tried to avoid typhoons, but storms moved unpredictably and sometimes caught the fleet. In December 1944, Admiral Halsey's Third Fleet steamed directly into Typhoon Cobra. The decision to refuel at sea despite deteriorating weather proved catastrophic. 3 destroyers capsized and sank. Dozens of aircraft were damaged or destroyed. 9 aircraft blew overboard from their carriers. Several pilots died when their aircraft were damaged or swept into the ocean. But typhoons weren't the only weather hazard. Squall lines, bands of intense thunderstorms, appeared with minimal warning. Flying into a squall line meant encountering severe turbulence, zero visibility, heavy rain, and lightning. Hellcats were tough aircraft, but even they could be torn apart by the most violent thunderstorms. Pilots caught in squalls sometimes became disoriented, losing control and crashing into the ocean thinking they were climbing. Icing was less common in the tropical Pacific, but occurred at higher altitudes. Ice accumulating on wings and control surfaces changed aerodynamic characteristics and added weight. Heavy icing could make an aircraft unflyable. Some pilots attempting to climb above bad weather encountered icing that forced them back down into dangerous conditions. Haze problems caused accidents even in otherwise good weather. Haze reduced visual range, making it difficult to see other aircraft. Mid-air collisions occurred when pilots didn't see each other until too late. The low contrast between ocean and sky in certain light conditions made altitude judgment difficult, contributing to accidents during low-level flights. Rain on the windscreen was more than an inconvenience. Heavy rain reduced visibility almost to zero. Pilots attempting to land in rain sometimes couldn't see the carrier until they were dangerously close. LSOs struggled to see incoming aircraft through rain, making their guidance less effective. Wet decks were slippery, increasing the likelihood of landing accidents.
As the war progressed and American industry produced aircraft faster than the Navy could train pilots, training standards were compressed. Young men who would have received extensive flight training in peacetime were rushed through abbreviated programs and sent to combat squadrons with minimal experience. The statistics reveal the problem. Early war pilots might receive 300 to 400 hours of flight training before reaching the fleet. By 1944, some pilots arrived at combat squadrons with barely 200 hours total flight time, and perhaps 20 to 30 hours in the Hellcat specifically. They were expected to perform carrier landings, night operations, and combat missions despite lacking the experience that made these tasks survivable. Carrier landing qualification, the training required before a pilot could land on an actual carrier, became particularly abbreviated. Pilots practiced on land-based runways with arresting gear, then did a handful of actual carrier landings before being declared qualified. Some pilots reached combat squadrons having made fewer than 10 carrier landings total. Then they were expected to land on a moving carrier at night, possibly while damaged or low on fuel. The accident rate among inexperienced pilots was horrific. Squadron records show that new pilots were far more likely to die in operational accidents than veterans. Some didn't survive their first week aboard a carrier. Others made fatal mistakes during their first combat missions, not because of enemy action, but because they lacked the experience to handle emergencies. Formation flying skills varied widely. Maintaining formation required constant attention and good situational awareness. Inexperienced pilots sometimes collided with their squadron mates during routine operations. Night formations were particularly dangerous, with pilots struggling to maintain visual contact with leaders while avoiding collisions. Emergency procedures required judgment that only experience provided. When an engine failed or systems malfunctioned, pilots had to make rapid decisions about whether to attempt returning to the carrier or ditch immediately. Inexperienced pilots sometimes made poor choices, trying to stretch their glide too far, attempting to restart failed engines rather than preparing for ditching, or hesitating when immediate action was required. The pressure on these young pilots was immense. They were flying complex, high-performance aircraft in combat conditions after minimal training. They saw experienced squadron mates dying in accidents. They knew their own skill level was marginal. Some froze during emergencies, unable to decide what to do. Others panicked and made situations worse. Yet they kept flying because the Navy needed pilots. Squadrons operated undermanned, with experienced pilots carrying excessive workload. New pilots were thrown into missions they weren't ready for because someone had to fly the aircraft. The institutional pressure to maintain operational tempo meant accepting accident rates that would be unthinkable in peacetime. The paradox of the F6F Hellcat defines its legacy. In air-to-air combat, it was devastatingly effective. The 19-to-1 kill ratio wasn't propaganda, it was documented reality. Hellcat pilots shot down thousands of Japanese aircraft while suffering relatively few combat losses. The aircraft achieved air superiority over the Pacific, protecting the fleet and supporting amphibious operations. David McCampbell, the Navy's top ace with 34 kills, flew the Hellcat exclusively. He described it as a pilot's aircraft, responsive, powerful, and forgiving enough to allow pilots to focus on fighting rather than flying. In McCampbell's hands, the Hellcat was an unstoppable weapon.
His famous mission on October 24, 1944, when he shot down 9 Japanese aircraft in a single engagement, demonstrated what a skilled pilot could achieve. The Hellcat destroyed 5,223 enemy aircraft during the war, 75% of all Japanese planes shot down by Navy pilots. It dominated the Battle of the Philippine Sea, the Great Marianas Turkey Shoot, where Navy pilots destroyed hundreds of Japanese aircraft in one of the most lopsided aerial victories in history. It protected carriers from kamikaze attacks during the war's final months. By any combat metric, the Hellcat was extraordinarily successful. But the operational statistics tell a darker story. Of the 12,275 Hellcats built during the war, over 6,500 were lost, more than half the total production. Only about 270 were lost in air-to-air combat. The rest, over 6,000 aircraft, were destroyed in operational accidents, carrier deck crashes, ditchings, mechanical failures, and other non-combat causes. The human cost was even more sobering. Roughly 2,500 Hellcat pilots died during World War II. Of those, only about 300 were killed in air-to-air combat, roughly 13%. The other 87%, more than 2,100 pilots, died from causes unrelated to fighting the enemy. They died in carrier landing accidents, from engine failures over the ocean, lost in storms, killed in mid-air collisions, or victims of the countless ways that Pacific naval aviation could kill without enemy intervention. The secret that killed 87% of Hellcat pilots wasn't a secret weapon or tactical innovation. It was the accumulated effect of dozens of small dangers: carrier decks that pitched in rough seas, engines that failed without warning, navigation errors over featureless ocean, weather that appeared suddenly, and the inevitable human mistakes that came from asking young, inadequately trained pilots to perform missions at the edge of what was physically possible. The F6F Hellcat deserves its reputation as one of history's great fighter aircraft. Its combat record speaks for itself, but understanding the full story requires acknowledging that most pilots who died in Hellcats never faced an enemy fighter. They died fighting a different enemy that couldn't be shot down, that didn't appear on radar, and claimed lives with relentless efficiency throughout the war. The next time you see a Hellcat in a museum or photographs of these fighters on carrier decks, remember the 87. Remember the pilots who survived combat missions only to die attempting routine landings. Remember the aviators who ditched in the ocean when engines failed and were never found. Remember the young men lost in storms, killed in accidents, or victims of the countless ways that Pacific naval aviation could kill without enemy intervention. They were the hidden casualties of the war's most successful carrier fighter. Proof that sometimes the most dangerous enemy is the one you can't see coming.